This section is on graphing parabolas. So parabolas are really of the form y is equal to ax squared plus bx plus c. So when we were solving quadratic equations, when you go and you put a y on the one side instead of like a 0 there, or set it equal to a number, just a y, and you have all the other guy on the other side, it looks like a parabola. And what is a parabola? What does it even look like? It looks like this, or like this, or like this, or like that. Okay, similar. And in function notation, it looks like this. F of x is equal to ax squared plus bx plus c. And then we'll introduce that notation as we need to. The value of a for the parabola is not equal to 0. Otherwise, the graph is linear. So there always has to have an x squared in the problem in order for it to be a parabola. And we've graphed linear equations. They're lines, right? But we already know how to do that. Now we're going to do this next piece. Okay, so there's like 5 bullets here. To decide whether the parabola opens up or down, the a value is your determining factor. If it's positive, the parabola opens up. Negative, the parabola opens down. The vertex, the x-coordinate of the vertex is negative b over 2a. What the heck is a vertex? It's either the highest point on the parabola if the parabola opens down, or the lowest point on the parabola if it opens up. Good? And then once you get the x-coordinate of the vertex, you can get the y-coordinate. Then we're going to make like a symmetry table to help us get some other points on the parabola. And then probably we're going to have to figure out where it crosses the y-axis and where it crosses the x-axis. Boom, bah, we're done. Go for it. We're going to use the steps to graph this parabola. Okie dokie artichoke. Here we go. So the first thing we're going to do is decide whether it opens up or down. And I'm going to do that by identifying A, B, and C. A is 1, B is 2, C is negative 3. That means the parabola opens up like a cup. Good? Now, because why? Because A equals 1, which is greater than 0. So we're all good. Next, we're going to get the x-coordinate of the vertex and develop a symmetry table to help us graph it. All right, so let's get the x-coordinate of the vertex. Okie dokie artichoke, here we go. What is it? It's x is equal to negative b over 2a. B is 2, so it'll be negative 2 over 2a is 1, so negative 1. So I'm going to develop a symmetry table, and I'm going to put negative 1 in the middle there. That's the x value of the lowest point on the parabola. So that's the x value of the vertex. Want to find the y value of the vertex? Yeah, let's. We know that y is equal to x squared plus 2x minus 3. So I'm just going to pop in negative 1 for x. Notice how I'm doing my nutshell thing. Negative 1 squared is 1. Take away 2, take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4. So the point negative 1, negative 4 in that ordered pair is the vertex. Yay! Okay? So we can graph that. We'll label this x and label this y, and let's graph in blue. Yeah. Negative 1, negative 4 is right here. Now, what do I mean by a symmetry table? Well, I'm going to go up from negative 1, bigger than negative 1 for a few points. Let's do 0 and 1, and lower than negative 1 for a few points. And I'm going to show you why this is so cool, all right, because it cuts your work in half, which is awesome. Okay, so if I put 0 in for x into my equation, x squared plus 2x minus 3, if I put 0 in, you guys, I'll get -3 out. Perfect. So the other point is 0, -3. Graphing in blue, 0, -3 is right here. And I'll label my points and my axes here. I should be labeling them. There we go. Now I'll feel better. Good. There we are. Now, let's put 1 in for x. So y is equal to x squared plus 2x minus 3. When I put 1 in, 1 plus 2 take away 3, that's 0. Cool? So 1, 0 is on the graph. So I take my laser, 1, 0. There he is, okay? Now, here's the deal on the parabola. The vertex, when you cut down the middle of a quote-unquote middle of a parabola, you cut it at the vertex. And this is called an axis of symmetry. Now, what does that mean? That means there's a mirror image from one side of the parabola to the other. So if I connect these points, you guys, then the other side has to be here, because that's my mirror image, and here. Neat? Now you guys probably don't, it's like the worst parabola you've ever seen in your whole life, but here's the deal on it. I'm hoping that it will work out that if I plug in -3 into my parabola, I should get out 0. And if I plug -2 into my parabola, I should get out -3. Good? So if I do that, I'm just going to do it so you can see. I'll just do it for -2 so you can see. Y is equal to x squared plus 2x minus 3. If I put -2 in, -2 squared is a positive 4. Take away 4, minus 3. Yay, y'all! -3. And then this guy will also be 0. See how cute? So just nailing that symmetry table, we're all good. Now we can answer the other two questions. Well, where does the graph cross the y-axis? Well, when x is 0, y is equal to -3 right here. So the y-intercept is the point 0, -3. You put 0 in for x, get y out. There it is. There's the y-intercept right there. Now, if I talk about where it crosses the x-axis, it actually crosses in 2 spots. And that's if you set y is equal to 0. So if I set y equals 0 in this equation, and I factor it, I get x equals -3 and x equals 1. And we got those. Where are they? They're right here. Foomp and foomp. So what are the x-intercepts? Are -3, 0 and 1, 0. Perfect. And you're like, well, that came right from the table. Yes, but sometimes you don't hit them like that. Okay, let's take a look at this one. Well, we realize that A is equal to 1, B is equal to 4, and C is equal to 4. So it opens up like a cup. So now let's build a symmetry table. Yeah, let's. So here we go. We need to get the x coordinate of the vertex. And how do I do that? Well, x is equal to negative b over 2a. So negative b, negative 4 over 2 times 1, which is a negative 2. So we're building the symmetry table. Negative 2 in the middle. And let's do negative 1, 0, and negative 3, negative 4. The beauty of this is I only have to plug in 3 values and the other ones will follow, which we love, right? So here we go. When x is equal to negative 2, we plug in negative 2 squared plus 4 times negative 2 plus 4. Negative 2 squared is a regular 4. Take away 8 plus 4. Oh, it's 0. So there we go, negative 2 comma 0. Now let's plug in negative 1 for x. So y is equal to negative 1 squared plus 4 times negative 1 plus 4. So 1 minus 4 plus 4. So that's 1. So bam-a-lamb, I have the 1 at negative 3. Done. Now let's do one more. Let's plug in 0. So when x is equal to 0, we get y is equal to 0 squared plus 4 times 0 plus 4. So y is equal to 4. Bam-a-lamb, I got the other one. So where's the vertex? The vertex is negative 2 comma 0. That's my vertex. Perfect. So let's graph. Label my axes, right? Graph the points. Negative 2, 0. Let's graph in blue. Good. Negative 1, 1. Negative 1, 1. And let's graph the other guy. Negative 3, 1. Good, because I got my little symmetry going on. I love the symmetry aspect of the parabola. And then 0, 4, and negative 4, 4, and then I can connect. Okay, perfect. So let's read it off the graph. What is the y-intercept? Where does it cross the y-axis? It crosses it at 0, comma 4. What's the x-intercept? Well, that crosses the x-axis at negative 2, comma 0. So in this case, it just comes down, touches the x-axis, and comes right back up. So it only crosses it once. And this is actually called tangent to the x-axis. You can impress your friends with that. One more example. Now we're going to do the last parabola. And what we're going to do is first I have to correct a little bit of a typographical error. It should say f of x is equal to negative 2 x squared minus 6x minus 4. So we're just going to cross that off for right now. Label our axes x and f of x. Now remember, f of x is just another way of saying y. But we like the function notation because we can see the input and output in the same sentence. So the first thing we're going to do is decide what a, b, and c are. So let's do that. A is equal to negative 2, b is equal to negative 6, and c is equal to negative 4. So first thing we're going to decide, is it up or down? Well, it's down because a is less than 0. So it opens down like a frown. Next thing is we're going to figure out the x-coordinate of the vertex. So x-coordinate of the vertex is x is equal to negative b over 2a. So it's negative 6 over 2 times negative 2. So this will become 6 over negative 4, which will become 3 over negative 2. And we really haven't encountered fractional results yet, but we can still do it because 3 over negative 2 is really negative 1.5. So we're going to still create our table using this. So we're starting off with negative 3/2, which is negative 1.5, correct? We'll get the y value or the f of x value in a second. Now we're going to take a look at going up and down from there. Well, basically negative 1.5. I can go to negative 1 here, negative 2, 0, and negative 3. And now we've set up a symmetric x value table, so it'll still be beautiful. Now all we have to do is plug in and get the function values. So let's do that. First, let's plug in negative 3/2. So we're going to do that first. I write down my function. And I'm going to plug in negative 3/2 for x. Now, let's do little evaluations here. We're going. So I'm going to plug it into my calculator, but I'm just going to show you that this is really 9/4 minus, this will be a plus 18 over 2 minus 4. So it's going to be negative 18 over 4 plus 18 over 2 minus 4. So let's continue. When I add those up, I'm going to get 18 over 4, take away 4. 18 over 4 is 4 and 1/2. Take away 4, so I'll get 1/2. So the vertex is negative 3/2, comma 1/2. Good? Now, when you go to plug in negative 1, let's do that one. If I do that, f of negative 1, I put negative 1 everywhere I see an x. When I do that, and I get my handy-dandy calculator out, I'll get 0. So this is 0, and this guy is negative 4 when you go to plug in 0. Then, so that means I have symmetry here, so that'll be 0 and that'll be negative 4. And I checked it just to make sure. So these are the points I'm going to be graphing on my graph. So I'm going to graph in red. Negative 3/2, 1/2. So we're going to go out negative 1.5. So negative 1.5 and up 1/2. Ta-da! Good, there's my vertex. Negative 1 and 1/2, comma 1/2. Good. And now let's do negative 1, 0. Negative 1, 0 is right here. Negative 2, 0. Yay. Negative 3, negative 4. There he is. And 0, negative 4. Perfecto. Now let's see if I can connect those. Not that great. Didn't connect those very well here. Let's reconnect. Good. And now let's talk the x-intercepts. The x-intercepts are negative 2 comma 0, and negative 1 comma 0. The y-intercept is 0 comma negative 4. And the vertex, we already talked about it, is negative 1.5 comma 1/2. Most math people will just express the vertex as just regular fractions, whether they're improper or not. Now you'll be able to do the assignment associated with this lesson. Good luck. Ask lots of questions as you need it.